You might expect that a car with only 2 wheels would tip over on its side, but not this car. It's called the Gyro X, and it's a self-balancing car. It does this through the use of a gyroscope. The front of the car is where the magic happens. This is the gyroscope which keeps the car balanced. To understand how this works, let's first look at a toy gyroscope. If you've never played with one of these before, then it can seem really strange at first. Once the disc in the center is spinning, you can do things like balance it on the edge of a string, or on the tip of a pencil. The gyroscope maintains its orientation. As the spinning disc slows down, it will start to wobble until it finally loses balance and falls down. More sophisticated gyroscopes will have multiple gimbals, so that no matter which way the frame rotates, the spinning disc can maintain its original orientation. This is extremely useful with a wide variety of applications, including airplanes and even space stations, so that they always know which direction they are facing. But there are some strange properties about a gyroscope that's not very intuitive. Let's say our gyroscope is spinning, and we try to rotate the gyroscope on another axis. The resultant force is actually 90 degrees in this direction. This phenomenon is referred to as gyroscopic precession. This is best demonstrated with another experiment. Here's a chair that can spin freely. Now we have a person sitting in the chair holding a spinning gyroscope. In this case, it's a bike tire, but this experiment will work with just about any rotating object. If the person turns the gyroscope, they will start to spin slowly in the chair. That is, by applying a torque to the gyroscope, the resultant force spins the chair. And if the gyroscope is turned the other way, the chair will spin the other way too. I just want to mention that the bike tire is spinning clockwise, but if the direction was reversed, then the chair would spin the other way. Now let's come back to the Gyro X car. Only 2 wheels here, so normally this car would tip over to one side. The gyroscope, however, keeps us balanced. Let's take a closer look. Peel away a few layers and you'll get to the flywheel. This is like the spinning disc in our toy gyroscope. This weighs about 230 pounds, and you'll notice that most of the weight is towards the outside. The hydraulic pumps will get it spinning at about 3,000 rotations per minute. The increased weight and speed, at least when compared to our toy gyroscope, means that the forces here are going to be strong enough to balance the entire weight of this car. The flywheel is placed inside of the gimbal housing. There's an arm that's attached to the side here. This is called the precessional ram. It's responsible for turning the gyroscope. This will happen when the control system senses that the car is off balanced or when the car is making a turn. Here's the gyro housing, and this is all put inside of a frame which then goes under the hood of the Gyro X car. So what happens here is that when the gyroscope turns, it creates a force strong enough to balance the car. It's the same effect that happens in the experiment with the swivel chair. It might be easier to visualize this if we turn the experiment on its side, and maybe ignore gravity. Turn the gyro and the person rotates. It's the same thing with the car. Turn the gyro and the car wants to rotate, or in this case, balance out. What I'm going to do here is show a few different situations and how the gyroscope will adjust. When the car is at rest, the gyroscope slowly turns to keep the car balanced. Now let's say something pushes against the side of the car. Boom. Notice how quickly the gyroscope has to respond to create a force strong enough to balance the car. The car also might get off balanced. This might happen in the case of the driver sitting off to one side. Now let's see the car in motion. Going in a straight line, there might be a slight wobble, just as we've seen before. When turning the car, the gyroscope helps assist in making the turn. Notice how it turns in the same direction as the front tire. I think that's pretty cool. When we're done driving, the 2 side wheels come down to stabilize the car, otherwise it would eventually tip over. The flywheel has enough momentum that it will continue to spin for up to 2 hours on its own. It's too bad this car never hit the production line. It would have been really neat to own one. But luckily, if you ever find yourself in Nashville, Tennessee, you can go visit the Lane Motor Museum to see this car in person. The museum specializes in unique cars from around the world with many unusual vintage cars that you won't see anywhere else. Thanks for watching, and I'll see you next time.